All right, I just want to go through some of the questions of the exam, I guess all of the questions of the exam, to show you how I would do them. So this first question asks for irrational numbers. Those are numbers that do not repeat, have decimals that don't repeat. Square roots are always like that. If they don't come out even. This one's not, because the square root of 25 is just 5, so that's not irrational. But the cube root of 5 doesn't come out even either. The only other one would be, I would say, this one, because it's showing a pattern that doesn't repeat. Maybe it could repeat in the future, but the pattern so far isn't repeating at all. So those are the three I'd select as irrational. Next question asks for interval notation. I like to draw a number line, put the number where it is, and it says x is greater than that. So it has to be going this way. And it's equal to, so it can be equal to -7. Then I just represent that in interval notation. So put a square, the smallest number is a -7, the largest number would be an infinity, and infinity always has a curly bracket. Okay, this property, it looks like they multiplied the x by each of those terms inside the brackets, and so this would be the distributive property. The next one, if I'm simplifying, and they're just monomials, so I multiply the numbers. So -8 times -5 would be a +40. And then if I'm multiplying common bases, I add their exponents. So it'd be x, 3 plus 4 is 7. Next question, I'm dividing. And so -48 divided by 8 would be a -6. Dividing common bases, subtract their exponents. And so 5 take away 2 is 3, and then y 7 take away 4 is also 3. This question, when it's a power of a power, but this power is negative. So the first thing I would probably do is flip everything over. And if you said flip everything over, I started giving you a point for that. Notice I didn't change any signs of the exponents. I just flipped everything over as it was. And then I changed the exponent up here to be a +4. Now, I can apply the 4 to everything that's in there. So it has to apply to the 2, and to this, and to that. So when I'm applying it power of a power, the rule is to multiply exponents. So it would be x to the -12, y to the 20th, over 2 to the 4th, I think, is 16. Then 3 times 4 would be 12. And -3 times 4 would be -12. Okay, I'm feeling pretty good. If you got to that point, probably 3 out of 5, because I should rearrange things so that I just have positive exponents. Okay, so to do that, I'm going to take this y to the -12 and put it to the top. And there's still a 20 there, and then I'm going to take this one and move it to the bottom. So currently I have 16x to the 12th. If I move this to the bottom, it'll be another x to the 12th. Simplifying here then, multiplying common bases, add their exponents. 12 and 20 is 32. And then 16, multiplying common bases, add their exponents, would be x to the 24. Okay, next question, determine the terms and the degree of the polynomial. The terms are just everything separated by a negative or an addition. So the terms you could just write as 6n4, -7n cubed, a -n squared, -4n, and a 15. And if they want to know what the degree is, it's always the highest exponent. It looks to be 4. So this would be a polynomial of degree 4. Here I need to subtract, so this is my dirty, rotten, filthy, stinking negative question, which there might be more of, cube plus. So I just write the first one, and then the second one, that negative, according to the distributive property, has to apply to everything in the next bracket. So it'd be a -8x squared, +7x, +x cubed, and a -6. Now looking at the highest degree, I have -x cubed, +x cubed. Those will cancel. Then my next, I have a 2x squared and a -8x squared. that would be negative 6x squared if you combine those. And then I have a 3x and a 7x, so that'd be a plus 10x. And then lastly, I have a 3 and a negative 6, so that'd be a minus 3. So that would be that simplification. Okay, next question was quite well done. This is just FOIL, right? So n squared plus 7n plus 8n plus 56. And since these are like terms, I would put them together. Plus 56. Same question with this one. So this one, and I like using colors. If it gets a little complicated, to use colors. So 9m squared. And then this one would be a plus 39mw. And then this one would be a minus 39mw. And finally, this one would be a negative 169w squared. So these middle two terms cancel because one's plus and one's minus. So my answer in the end will be 9m squared minus 169w squared. Okay, then they ask us to factor out the largest common factor. I think 7 will go into both of those. And also the m squared. So I can divide each thing by 7m squared. So to rewrite that, I'd write what I'm factoring out and then what I get when I do that division. So this first thing, I'll be left with an m squared minus. This one, the m squareds cancel. 21 divided 7 is 3. Okay, next question. Factor this trinomial. I like to do it with the guess and check method. So I'm just going to guess 3y and 2y. And then the 12 has to be 4 and 3. I'm thinking a 3 there and a 4 there. Since this sign is positive, both signs have to be the same. Since this sign is negative, they both have to be negative. Let me just confirm that. 6y squared, okay, negative 9y and a negative 8y. Sure enough, that gives me negative 17. Negative 4 times negative 3 is negative 12. So that means this is correct. If you like doing the AC method, you'd multiply the 6 by 12. So you'd have to get two numbers that multiply to 72 and add to a negative 17. Okay, I think negative 8 and negative 9 are our numbers. And so I split up, well, let me just write the question again. So I split this term up into 2. So 6y squared minus 8y minus 9y plus 12. And then I'll do group factoring. So out of the first two, I think I can take a y, leaving me with 3y minus 4. The next one, I can take out a negative 3, leaving me with 3y. 12 divided negative 3 is a negative 4. Okay, now this term and this term, they each have a 3y minus 4. And then I'd be left with 2y minus 3. Okay, next question, factor a difference of cubes. First thing you need to do is to know what a and b are, because I know my formula is a plus b, or a cubed plus b cubed. The formula would be a plus b, and then a squared minus ab plus b squared. That's my formula. So I need to know what a and b are. So for the first one, it's fairly easy. It'll just be t. And for the next one, if you cube 7, you get 343. So then I just plug a t in everywhere I see an a, and I plug a 7 in everywhere I see a b. So it should come out looking like this. It'll be t plus 7, and then t squared minus t times 7, or just 7t, plus 7 squared, or 49. If you wrote 7 squared, I accepted that. Next two questions I need to solve. They're both linear equations, so I need to get x's on one side, numbers on the other side. For this one, I'll add 12 to both sides. So I'd get negative 3x is equal to I think that's negative 36. And then we'll divide both sides by negative 3. So x is equal to a positive 12. And if you wanted to, you could check that. Negative 3 times 12 minus 12. Does that give you negative 48? Negative 3 times 12 is negative 36. And if you subtract 12, sure enough, gives you 48. That means my question is, or my answer there is correct. Okay, next question. This one you have to be careful with. A lot of people subtracted those two. But you can't do that because 3 is being multiplied by x plus 6. So I have to do the multiplying before I do any subtracting. Okay, so the first thing I would do is take this minus 3 and multiply it by both things inside the brackets. So it'll be minus 3x minus 18 is equal to, same thing on this side, 8 minus 4x minus 20. If you got to that point, I gave you a point or so. Now, I like to just sort of swap everything. Notice if I'm swapping across an equal sign, they change signs. Some people tried to change a sign both on one side, and you can't do that. If you're moving something from one side of the equal sign to the other, then you would change its sign. So what I'll do, and I'll maybe show you. So I'm going to add 4x on this side. If I do that, I'll add 4x on this side. So that'll leave me with 7. That'll be plus x minus 18 equals 8 minus 20. Now you could combine those already if you want. Or you can say, well, I'm going to subtract 7 there, and I'll add 18. So if I subtract 7 on this side, I have to subtract 7 on the right side. If I add 18 on the left side of the equal sign, I have to add 18 on this side. Okay, so these cancel. I'm left with x is equal to 8 take away 20 is negative 14 minus 7 plus 18. Negative 14 minus 7. Did I do that right? Oh, it's not 14, it's 12. I made that mistake when I was doing that on the test too. It's minus 12. Minus 12 minus 7 is negative 19. And negative 19 plus 18 is a negative 1. And again, you could take that number and plug it in everywhere you see an x up here and see if one side's equal to the other side. I think I did that in the answer key. Okay, next question they ask you to solve. And for this one, you need to factor. Since it's a quadratic equation, you need to factor. Let me make it a little bit bigger. Okay, so to factor this, it'd be x plus 9 and x minus 3 is equal to 0. And so when you're solving an equation, you use that 0 property. So if something times something equals 0, either x plus 9 is 0 or x minus 3 is 0. And solve each of those linear equations. So this would be x equals minus 9, this would be x is equal to 3. And so these would be the two answers. When you check that, be careful, like if I were to check the minus 9. So my formula is x squared plus 6x minus 27 equals 0. That's my equation. When you plug a negative 9 in there, don't do that. Because a lot of calculators, including decimals, will give you an incorrect answer on that. You need to square everything that x is. So your calculator, what it typically does is just squares the 9. It doesn't square the negative. So to make sure that you get that correct, you want to put this in brackets. Okay, plus 6 times minus 9, minus 27, is that equal to 0? So negative 9 squared gives you a positive 81, minus 54, minus 27, indeed gives you 0. Okay, so careful with that. Next question, they want you to solve this for b. So they want b on a side of the equal sign by itself. First thing I would do is just multiply both sides by 2. So I'd get 2a is equal to, the 2 times a half cancels. So 2a is equal to b times h. And then if they just want to know what b is, now I'll just divide both sides by h. So b then will be equal to 2a over h. Some people had divided by a half, and if you did that, that's okay, but you do want to simplify. Like some people had a over a half h like that. But that's a complex fraction, and so you do want to simplify that. I think I might have given you points for that, but... Okay, next question, divide and simplify. These are quadratic expressions, so I want to factor each of them. So the top one, you get z plus 3 and z plus 8 over the bottom is z plus 8 times z plus 8. The other side, I'm going to change that divide to multiply, and so I need to flip both of these. So on the bottom I'll have, oh, that's not a 3 terms, so I just can take a z out. And then the top will factor to z plus 8 and z plus 2. Okay, then I can hack and slash. There's a, whoops, I didn't mean to erase it. I meant to cross it out. That one goes and that one goes. Oh, there's a z plus 8, z plus 8, z plus 3, z plus 3. So on the top, I'm left with z plus 2, and on the bottom, a z. Some people tried to cancel those, but you can't cancel them because of that plus sign that anchors it. This z would be a common denominator. So you could re-express it like this, z over z plus 2 over z. And z over z is 1, so you could call it 1 plus 2 over z. That would be correct. But this is probably preferred. Okay, next question. I'm subtracting rational expressions. So to subtract rational expressions, I need a common denominator. So I'll leave the 4x there, and the bottom I need to factor. So it's minus 7 minus 3. And 3x over. The next one is x minus 7, x minus 4 when you factor it. Okay, to get a common denominator, it looks like 7, 3, and 4 would be my common denominator. So I need to multiply this one by an x minus 4. And this one I need to multiply by an x minus 3. So, and I said this in class, now I have my common denominator. And before I do anything up top there, I just rewrite it. So 4x times x minus 4 minus 3x times x minus 3. And I have you rewrite that so you can identify that minus 3x has to multiply by both. And so there'll be a negative sign that will mess up if you don't do that correctly. Okay, let's FOIL this part. So that'd be 4x squared minus 16x. Again, I did that on the test. I was going to put a 4 there, but it's a 16x. And then a minus 3x squared plus 9x, all over that common denominator. Okay, looks like I need to come over here now. So on the top, 4x squared minus x squared would just be an x squared. Negative 16 plus 9 would be a negative 7x over the common denominator. Okay, and then if you got to that point, I'm giving you most of the points. But the top, you could factor that to x and x minus 7, taking out a common factor of x over the common denominator. And when you do that, in this particular case, I do have a common factor on top and bottom that I can eliminate. So my answer should be x over x minus 3, x minus 4. Fairly tricky question. Okay, the next one asks you to rationalize the denominator. So to rationalize the denominator, I need to multiply both top and bottom by the conjugate of the denominator. So that'll be root 7 minus 2 and root 7 minus 2. Oh, that's a 7. Okay. All right, so let's do the first one. Root 7 times root 3 would be a root 21. Root 3 times that will be a minus 2 root 3 over, on the bottom, root 7 times root 7 is the square root of 49. Oh, which will come out to 7. Root 7 times minus 2 is a minus 2 root 7. And then 2 times root 7 is a positive 2 root 7. And lastly, 2 times a minus 2 is a minus 4. So on the top, I have root 21 minus 2 root 3 over root of 49 is 7. These two are additive inverses of each other, so they cancel. And so the bottom, I just have 7. Okay, with this question, you want to simplify, so we're looking to get common radicals so that I can add things. Maybe I'll just try the first one. It's 5 root, now 12 is 2 times 3. There's 2 2's inside, so I can bring 1 2 out and multiply. Since this one is a root 3, I assume you can get a root 3 for those as well. So plus 8, if you divide 3 into 192, I think it goes 64 times. So it'd be the same as root 64 times root 3. Plus, minus 4. 108 divided by 3, I think, is 36. So that'd be root 36 times root 3. And fortunately, the square root of 64, I can get, that's 8. And the square root of 36 is 6. And now I have everything that's root 3. So let's just figure out what their coefficients would be. 5 times 2 is 10. 8 times 8 is 64. 4 times 6 is 24. 10 plus 64 is 74. Minus 24 is 50 root 3. All right, hopefully that helps you with that exam.